So we all kind of know that the pandemic is coming to an end, and very soon, if already not happening, students should be coming back to school already. I'm not sure how many of your schools the students are already coming back, but around the world, students are beginning to return to school on regular basis. Students and the teachers are now returning to the school building to have face-to-face instruction as before. But I'm hoping that it is not as before in general. If before was the teacher giving a lecture, if before was the teacher explaining everything, if before was a lesson in mathematics where the teacher show a formula, say to solve quadratic equations, and the teacher show a work example, and the students try 1 or 2, and then they go home and practice maybe 10 more. And in a test, they get more or less the exact same thing. If before was like that, I hope we are not going back to before. And that is today's topic, recovery from the pandemic. When the students come back to school, this is one good opportunity for us to recover from the mathematics education pandemic, where many students before did not learn so well. Many students before did not enjoy the subject of mathematics. Because students in the last 2 years, teachers also, and parents, society in general, they have now become exposed to the use of technology in teaching and learning, like what you and I are doing today. So society has now become quite exposed, and technology is now becoming quite acceptable as a platform for learning, for teaching and learning. Recovery from the pandemic. Hopefully today, we are able to see very, very clearly 2 things. 1, what are some things I should not do as a teacher of mathematics? Number 2, which aspects of a lesson should or better be done via technology? This is really our one chance to change things fundamentally. Such opportunities don't come very often, but the COVID-19 pandemic, as it is becoming endemic, or some people say coming to an end, is really a good chance. How many of us are guilty of disciplining students when they are in class? How many of us are a little bit guilty of the fact that I can control them only if they are in front of me? I can manage their discipline if they are in front of me. If they are not in the same space with me, I have no control over how they behave. So are we somewhat guilty of that? I don't think anyone does it intentionally, but some of us, in our enthusiasm to give students good discipline, may have put in artificial strategies for good discipline. Artificial strategies for good discipline means students will behave when I am there. But the moment I am not in class, they will be up to nonsense. They will do their work if I'm standing there in class, maybe looking over their shoulders. But when they're asked to do homework at home, they cannot be bothered. They rather do their own things, playing football, which is not a bad thing, or spending all their time playing computer games, which is a bad thing. But they will not do my homework. And some days they will do it, because the next day when they meet me in school, I will reprimand them. And because they don't like to hear me scolding them, they will copy their friends' homework just to submit to me. Not because they want to do it, not because they do it to learn, they do it to get me out of their hair. So I just want to end this opening segment by asking us, have we, in our enthusiasm to discipline students, because we all know discipline is important in one's life, have we used genuine strategies, or are we using artificial strategies? Artificial strategies for discipline, also for mathematics learning, means they do well if the teacher is around. They don't do well when the teacher is not around, whether for behavior or for mathematics. Do some of us see students who are okay when they are doing their classwork, when we are there with them, but when in a test, independently, they are not able to perform. So yes, that is one topic we are going to discuss today. Mathematics is hard to learn. So that's another topic we are going to discuss, which is a topic of motivation. How do we motivate students? Because we do know that motivation is quite important in successful learning. In fact, for anything, not just for learning, not just for learning maths. I think for every human activity, for every human endeavor, unless there is motivation, usually we don't get very good results. So motivation is important. There are two kinds of motivation, what educators call extrinsic motivation and intrinsic motivation. Extrinsic motivation is the motivation because of something external. Example, I better do well in maths because the teacher is very fierce. He will scold me if I don't get a good score. I better do well in maths because my parents already said no reward if I don't do well in all my subjects. Maths is one subject, so I have to do well. I don't like it, but I will still study because I want to get the reward from my parents, or I want to avoid the scolding from my teacher. Are examples of extrinsic motivation. Intrinsic motivation, I assume, is the one our friend just talked about. Motivation that comes within a person. As simple as, I like learning. I just like it. No reason. I just like it. It's something I enjoy doing. I don't know the reason. I just like it. Or some of them do know the reason. I enjoy mathematics because it makes me think. Mathematics problems that are challenging, they are the best because they make me think. I don't know about you, but for many of us, this game that has been going around, Wordle, not sure whether it has become a rather popular thing in Indonesia, where you have to guess what the word is. There's a Malay version as well called katapat, where you need to, just guess what the word is. Some of you who are older might remember the game called Mastermind. So they will tell you, when you guess the word, they will tell you, oh, the letter you guess, is it in the right spot? It's a 5-letter word for the English and Malay version. And sometimes they'll tell you, oh, the letter is in the word. The letter is in the word, but it's in a wrong place. And then they'll also tell you, oh, that letter is not in the word. Like Mastermind, the game called Mastermind. And for me, I find that challenging. And I think for a lot of people, we find it challenging. How on earth do we guess the right word in 6 attempts? Among the many words in the world, like 5-letter words, there are so many. How can I guess it in 6 attempts? Sounds almost impossible. No context, no nothing except the clues of whether the letter is in or the letter is not in, or the letter is in the right spot or not. So it's quite difficult, but the game has taken the world by storm. So some students will say, oh, I like it. Yeah, it's difficult, it's challenging, but I like it. So those are examples of intrinsic motivation. We like something, and we may not even know the reason. Also, we like something, and we know the reason. And the reason is something internal to us. I like it because I find it challenging. I like it because it makes me think. I like it because it's useful to me. Right? So today we are going to also be talking about, when students come back to us, what are some things we can do? And the short answer is the learning environment. The learning environment, the classroom culture. What we already know about motivation. We are not very motivated. We are not very motivated when we are put in an environment where we are always a little bit fearful. Fear is one of the most negative things human can ever have. Whenever we have fear within us, we cannot do many things. And worse, sometimes the fear will eat at us. It will eat us up a little bit every day. And many students suffer from that disease. They have fear. Not sure what they are fearful of. Sometimes they are afraid of the teacher yelling at them. Sometimes they are fearful of the teacher being sarcastic and embarrassing them. Sometimes they are fearful of getting the wrong answers, and then everyone seems to be laughing at them. Whatever the fear is, if they have that fear, every day, the fear will eat them up to the point where they will say, oh, I don't like maths, I hate maths, I don't want to have anything to do with maths. Yeah, so today we're going to be looking at that, but the short answer is the kind of atmosphere the students are in. Are they in an environment? Are they in an environment that is nurturing? Or are they in an environment where they are being controlled? Who are in a learning environment where everything is controlled. Boys and girls, listen to me. Do this way. No, your idea is good, but do it this way. Because in the exams, I want to see this. So such environments are not really good at all for students to be in. So fear and being controlled are two important things that make students not motivated, because the motivation will be taken off them the moment they are fearful, because they spend all their resources, cognitive resources, being frightened, and they got none left to learn or to be motivated to learn, or they spend all their resources trying to control themselves of being angry because they were being controlled by the teacher, and they have nothing available to learn, to be motivated to learn. So yes, today we are going to be looking at that. And the third topic we are going to look at today is maths only for maths? Actually, it's okay for students to grow up, go to university and study business, study accountancy, study law, study whatever, interior design, performing arts, which have apparently no direct connection to mathematics. That's okay. We don't need everyone to study mathematics. We really want young people to study what they enjoy as their major when they are older. But is it true that mathematics is only for mathematics? Is the learning that they have in mathematics classroom at O levels, at GCSE, also applicable to when they study law at university? So that is something else I would like to talk about. So these are our three main topics today. How to help students learn mathematics easily, naturally. How to increase motivation. As well as, is it true, mathematics is just for mathematics alone, right? Let's go on to the next part for today. So the main part for today's session is for me to help you identify what it means to recover from the pandemic. To recover from the pandemic, both the pandemic of mathematics education not being done well, also the pandemic of COVID-19, to recover from the pandemic means three things. Number one, if we are really serious, sincere about recovering, we must find ways to make sure mathematics is not hard to learn. Number two, it means finding ways to make the learning environment not a fearful one, not one where we control everything. Make the learning environment a nurturing one. Thirdly, the perception of the usefulness of mathematics. Many people, even adults, even some teachers, have misconception about using mathematics. Many people think using mathematics in a literal sense. I learn quadratic equation. I use quadratic equation when I go to the market, or which I don't. I learn area of trapezium. I must use the formula in calculating carpets in my room. Many people have that wrong misconception. They always think of using mathematics in the literal sense. Yeah. So the third thing we need to do about recovering from the pandemic is to change the mindset amongst our students, their belief system about the usefulness of mathematics. The rest of the session is for us to look at examples, how those three things can be done. But I just want everyone to be very clear what it means by recovering. Make mathematics natural, make learning environment nurturing, and make students have the right belief system about mathematics and mathematics learning. Those are the three most important things we all, or as a school, as teachers in a school, we all need to be paying attention to, right? Let us now go on to the next part. When you meet with your colleagues, you can share your idea, how you can help students learn naturally, how you can help students learn in a nurturing environment, or how you change students' perception about what mathematics is. Anyway, I have just shared with you a diagram, a figure. Yeah. So we call this a figure. A figure is a diagram. Yeah. So you see a figure, right? And yeah, as normally what we do is a convention, right? We kind of just name points. In this case, they are vertices. Yeah. The corners, the vertex, the vertices, plural. Vertex, vertices, corners. Is conventional. We use capital letter, yeah, to name vertices. So you can see some points, A, B, C, D, E, yeah. And you know points, you draw points, you draw, if you join up points, you can get a straight line. Not always, you can draw a curve, but here we get straight lines, yeah. So anyway, the figure is formed by straight lines. Is that easy to understand? The figure is formed by 5 straight lines. Okay, can we see the 5? I can see some. Okay, I can see this. I can see this 2. I can see 3. I can see 4. I can see 5. All right, so I can see 5 straight lines, and they tell me, yeah, that is it, AC. Yeah, AC, we can see AC, yeah. Yeah, so those are the 5. So those are the 5, I trust them. Yeah, those are the 5. Anyway, this is it. I didn't give you a question. I'm just wondering what questions you think we can answer given this information, right? So that is the mathematics task. What are the questions that we can answer? Yeah, just one question or 2, but if each of you contribute 1, your group will have many already. Yeah, so those are the 2 things we are going to do for 15 minutes in our group. All right, so 2 things. 1, just share how you can solve one of our 3 problems. which is recovering from the pandemic. Make mathematics not hard, natural. Make learning environment nurturing, and make the belief system for students to be the right one. And if you like to talk about it in relation to a mathematics task, here is one mathematics task. And the mathematics task is what questions we can answer given those information. Yeah, so the values of three angles are given. Yeah, you can just take note of that. Yeah, so I hope some of you are remembering the diagram so that when you go to the group, you can just help some friends who may not be able to record the diagram in their mind. Yeah, so that's a diagram, just 5 lines. Yeah, some of you thinking star. Yeah, it looked like a star shape. Yeah, so yeah, a star shape. Star shape is a nickname, not a mathematical name, but it's okay. Star shape. It looks like a star, and the 3 angles are easy to remember the value. It's 31, 41, 51. Yeah, quite easy to remember, but some of us might forget. It's okay. Our friends who can remember will help us remember. Right. Anyone would like to share something before I give my inputs? Some of you are sharing in the chat room. That's fine. But any of you would like to share orally? That's also good. Some of you are already sharing in the chat room. You can take a look. Some of the questions they think. So some of them say, okay, maybe they want to find the sum of this angle and that angle. Yeah, right? So yeah, some of you say you can find the sum of those 2 angles, but individually, we do not know. Okay, so those are some interesting questions. So I think the general question is, can we find individual angles? How many of the individual angles we can find? The measure of each angle. I mean, 3 are given. Are there others that we can also find? So I think some of you are discussing that, right? And then some of you also talk about, okay, I cannot find the sum. I cannot find the measure of individual angle, but I can find the sum of. Example, some people were saying, oh, we could tell you the total of these 2, but we don't quite know the actual value of each. How can we make mathematics more natural? Or how we can have a nurturing environment? Or how we can change mindset for students? And any of you would like to talk to us orally?
For me personally, if we want to make math more naturally, we have to take example from our daily life, from our what we see every day, what we see, what we feel every time we can, yeah, everything we start with our day. So we can take an example, just like maybe in the angle, we can just say, oh, the angle of our shape is just like 90 degree. We can say 90 degree is, we put in a lot. It's just like in our chair, in our building, is almost take a lot of shape and angle. We can take a common example that we use in our usual day. So they will find, oh, actually, I know about this also. So it will become more naturally if we just taught them. We can, it's this problem actually appear every day in our life. I think so.
Yes. Thank you very much. Thank you very much. Right. I will now just show a little.
Pineapples are sold at 20 baht each or for 50 baht for the smaller variety. Write expressions for the greatest number of pineapples that can be bought with X baht.
Yeah, so just a little TikTok video that, I don't know, 15 seconds, maybe less. I don't know how long that was. A simple TikTok video that, kind of get students to pay attention to something that they probably see every day. Pineapple. This is Thailand. Pineapple. So some of you do know, I also run a Singapore school in Thailand. So I also produce materials for my colleagues to use. So this is just one of my little things. I just produce very short videos like that, yeah, based on things around us. And I think that's what our friend was sharing with us, yeah. One strategy is to present mathematics starting with things around us. And like what our friend was saying, is not difficult actually. Yeah, so this is just a little example from algebra where they're asked to write expressions. I think in secondary one, for those of you who are using Think Mathematics or the new syllabus mathematics, the latest edition, it's called Think Mathematics. Secondary one, they write expressions for algebra. They are learning to write expressions. Yeah, and yeah, this is something they can do, writing expressions for something. In this case, the greatest number of pineapples that can be bought with X bar, where X can be any number, right? And they were told in the video, the pricing system. If you notice it, the pricing system is a little bit crazy, yeah? Anyway, things like that is quite useful. So thank you for that input. So I have purposely given you a problem that is context-free. Like this is just a pure mathematics problem. Nothing wrong with pure mathematics problem. But one strategy that our friend just shared with us is to always put this in context. For example, you can find a picture of a Japanese temple that include a figure like this. Or you can find a structure built from bamboo in a more traditional setting where they use bamboo to create a structure like that in a restaurant. I'm sure you can find something. Like our friend shared with us, it is not difficult to find something just to introduce. Oh, okay, you know, actually, this is the structure they use to make that place that they have in a restaurant, yeah, with the atap roof and then bamboo structures like this. Oh, okay, you know, in this Japanese temple, interestingly, they have this design on the entrance, one of the wooden things that they carve. There's this star design that they have included. Anyone would like to share with us what is one important thing? Our friend already earlier said, one important thing is to introduce the line AE. So that's one important thing. So for them, the one important thing is introduce the line AE. So they believe that once they introduce the line AE, they can find other things. Example, they can find this angle. And once we find this angle, we know the angle Y. Yeah, maybe I call this angle M. Yeah. So that is what we mean by one important thing. Some of you say another important thing is properties of triangle. What about properties of triangle? Oh, do you mean that triangles, interior angles, sum of interior angles in a triangle, we know? Oh, also about the sum of opposite interior angle. Okay, so some of you are saying two things, right? I don't understand everything clearly. So let me check if I got you right. Okay, so one important thing some of you say is about triangles. Do you see a triangle that's useful? Oh, I see a triangle that I think is useful. I'm not sure whether you agree, but you don't have to. I think if I see this triangle, it's going to be useful. Is that right? Oh, so some of you say we know this angle, this angle, this angle add up to 180 degrees. Or some of you say it nicely. Some of you say the sum of interior angles in a triangle is 180 degrees. But for me, I like simple language. So I'll just say these three add up to 180 degrees. But yeah, some of you have a very nice way of saying it. Sum of interior angles. Okay, I think I can use that to find x, right? Oh, that's how you found x. Some of you found the value of x. And then some of you say, some of you also say about the sum of the interior angles, or the opposite interior angles. Also, you mean these two. So you say that, okay, if I add up these two, so that is your opposite interior angles. Oh, okay. So some of you say that those two values is also equal to, the exterior angle. So somebody said something that I didn't understand earlier, but I think now I understand. So somebody said sum of opposite interior angles. So opposite to this, yeah? So opposite. So this one and that one, opposite. So sum of opposite interior angles. Oh, that's equal to the exterior angle. Also, are you just telling me that if we have a triangle, then if I know these two, I will know that one. I think this is easier for me. Yeah, the words are quite difficult, but I think this diagram says it right. The two green equal to the red. Is that what you meant? Oh, so some of you say that is also useful. Oh, somebody else also talk about vertical opposite angles. Oh, so are you telling me that if I got two straight lines, then these two angles are equal? Oh, that's what we mean by vertically opposite angles. So some of you are good with words. You use words. Some of us are better in diagrams. We use diagrams. Yeah? So up to you. So later in your notes, I would like you to make a list of properties that you use to find the different angles in the diagram. Yeah? And when you give the property, please give me the diagram like this, but also give me the words. For example, for this diagram, the property we are using is vertically opposite angles are equal, right? So that is what we are going to do for our notes afterwards, for our journal afterwards. In our journal, please draw the diagram that I've given you and try to find a few angles, at least one, but if you can, two, if you can, three, but any number. And please make a list of properties that you are using. When you make a list of property, please have the words, but also the diagram. Just in case some friends not so good with words, they can use the diagram. Okay, right, let me pause here. Anyone else would like to share some things you notice what I'm doing with you? Yeah. Anyone else would like to share with us some thoughts, some observation of what I have done with you as far as, the mathematics teaching is concerned? Right, if not, before I summarize for today's session, maybe we look at one more problem. Yeah, I mean, just a typical IGCSE problem. Yeah, just a common IGCSE problem. Right? So that's an IGCSE problem. All right, class. One of the problems that we have for homework that many of us seems to not do too well in is this one, right? So in this homework problem, we are supposed to rewrite. We are supposed to rewrite this expression in this form. So we are supposed to write this expression in this form. Yeah, express just means write. Yeah, that's right. So that's what it means by express. It comes from the word expression. Expression is something I say or something I write. So to express is to say or to write. Yeah. So in English, we got expressions like to kill two birds with one stone is an expression that I can say, I can also write. In mathematics, we also have symbols. So we can also express, meaning to say or to write using symbols. Yeah. So that's what you mean by that. Okay. And the useful things about this expression is we have a square. Is there something we know about square? Is there something that we know about the square of a number?
Yes.
Yeah, the square of a number. We know something about it, right? That's right. It cannot be, it cannot be negative, right? Yeah, so something special about the square of a number is that we know, like the minimum it can be. Yeah, so I don't even know what that X and Q is, but I can tell you for sure. So are you able to tell your friends what's the minimum value of the square of a number? Doesn't matter what the number is. Here, our number is this. But do we know the minimum of a square of a number? Oh yeah, is that right? So many of you say, yeah, it cannot be negative. Of course, it can be positive. Example, square of 3 is 9. Square of 7 is 49. Square of -2 is 4. Is that right? Yeah, square of -2 is 4. Oh, so yeah. So this one, the minimum has to be 0. In other words, we also know the minimum of this whole thing. Is that right? So if I know the minimum of this is 0, then if they ask me the minimum of the whole thing, yeah, it has to be the p value, right? Whatever the p is. Yeah, okay. So that's useful. That's useful to write it in this form. Oh, by the way, some people will call this form completed square. It's just what people say. So in future, if your friend say, write in completed square form, that's what it means. Yeah, but anyway, it's just a language, yeah? Completed square form. So when people say complete the square, it's like that. Write it like that, yeah? When people say, oh, please complete the square, they mean do this. Write it in square of a number plus something. Useful? Why useful? Yeah, because we can always find the minimum. Yeah, we can always find the minimum. Oh, no wonder they asked us later to find the minimum point of this value. So this is what we have already. Yeah. So do you see how you can do part B afterwards? Right? Right, colleagues. So you'll notice that my explanation involves questioning. Oh, do you know something about the square of a number? Do you know the minimum of the square of a number? Yeah. So you notice that my explanation is not explaining. So I didn't explain actually. My explanation is asking question. Second thing you might notice is I focus on one thing. In this case, I've chosen to focus on the usefulness of the completed square form. Do you notice I didn't even talk anything about the actual completing the square? Maybe I want to also do that, but I will do that separately. Whenever I'm helping students who are finding this problem difficult, I need to focus. Yes, there are two things here. One is the act of completing the square, and second one is interpretation of the completed square. Two things. In my explanation, I need to pick one. If students have problem with both, you do one by one. Don't do all together. Because they need help. Yeah, like one of you was saying earlier on, you notice that one of the observations you make, you notice that instruction must be clear. When we say instruction is clear, one of the many things it means is that don't teach everything. Yeah? Don't teach everything. Choose what you want to focus on. If students have problem with everything, then that segment focus on one thing. So the two things I'm talking to you about is use questioning, not explaining. Yeah. And second one I talk about is having a focus. Anyone else would like to bring up something more? Okay, right. I suppose a different segment of the lesson or a different lesson. So, well, here we have the square of x, and then we have a bunch of x. Oh, let's say we have only, let's say we have only 2. Can you see what we need to do to complete the square? So let's say we have expressions like the square of x together with 2x is not yet a square. Can you see what we need to do?
Add the yellow.
Yes, add something in the corner, right? So you know what to add. Yes, add 1. So if we add 1, we can, yeah, we can complete the square. Yeah, so yeah, we can do that. We can do that. Can you see what we need to do if we have expressions like this? Which is, you know, the square of x together with 4x. Right. So some of you do see it. Yeah. You say that we need to add. We need to add 4 to get a completed square. Yeah. So you can do that, but if you want to say the square of x together with 2x equals to, yeah, I suppose we can. So we just need to complete the square. And from here, we can see that this is really 2 more than x, right? So that's 2, right? 2 more than x, isn't it? So we can see that. We can see that this is a square having sides of 2 more than x. So this is a square of 2 more than x. Yeah, or some of you say x plus 2, the square of x plus 2. Yeah. So yeah. So if you want to have this value, if you want to have this expression, yeah, we have it. We can get it from the square that we have, but we need to take away. We need to take away that, yeah, because yeah, that's right. So that's what it is, isn't it? So we need to take away. We need to take away whatever that we don't need. Yeah. Okay. Yes, this is Braining Camp, yeah, the app. So yeah, I would like, so in class, I will tell the students, I would like you to explore other expression. You can just make your own. You can just make your own. Example, I can make my own. I can have 3 now. I can have 3 of it now. Yeah. So like for this, I wonder if I can write it as, so this will be 6 of it, right? So square of x together with 6x. If I can write it as a square and then plus or minus whatever. Yeah, I just write plus because it can be plus a negative number as well. Yeah, so I just write it like that. Yeah, so I wonder if you can just go and pick your own expression and do that. Yeah. So yeah, if I want to focus on completing the square. All right, any of you would like to bring up questions? Or okay, now let me use that to now begin to summarize. Mathematics is hard to learn. How do we recover from the pandemic of students finding mathematics difficult to learn? Yeah, some of you suggested using visual. Yeah, others are either asking or sharing ideas. Yeah, somebody did share a difficulty. The problem, sometimes students don't answer the teacher's question, even though you ask them many times. Yeah, and especially when you do online, it's like talking to the screen. Yeah, so that is probably something they have learned. So maybe when they were in primary school, or maybe last year, the teacher who taught them did not expect them to talk. So now when you ask them, they don't answer you because they believe that mathematics learning is paying attention. Yeah, paying attention. How often in class do we say to them, boys and girls, keep quiet, listen. If they have been exposed to that kind of instruction, pay attention, listen, look at the board. Where are you looking at? Look at the board. If you don't look at what I am doing, how are you going to know? So many students have come from classrooms where they hear that a lot. That's belief system, right? The third question, belief system. Many students have the belief system that mathematics learning is listening. Mathematics learning is paying attention. So no wonder when you ask them question, it's very hard for them to answer. In class, they are in front of you. At least you can force them. So, like, Ali, tell me the answer. John, tell me the answer. And then reluctantly, they stand up. And then they stood there for like 20 seconds, wasting time. Right? Yeah, so that is a problem. That's why I say it's a pandemic. Our students are suffering from the disease of not learning mathematics well. They don't think that talking is part of learning. They have come from a classroom where talking is not a good thing. And whenever we ask a question, it's always asking for the answer. And if they don't know the answer, they got nothing to say. Right? So how can we change that? We are now getting to the final summary. I hope you have noticed some things that can help us in answering the question. Yeah, so some of you have also pointed out that, yeah, math is hard. Because even before they learn it, they already think it is hard. So that's a belief system, a misconception. They already decided mathematics is hard, even before they come to the lesson. So, yeah. So many of you also talk about visual animation. Yes. What are some good resources or literature to help us improve our ability to state the correct question? Do you mean some resources? What do you mean by the correct question? I don't quite understand that. If you can clarify that. Can our friend Ariel, who asked that question, help us clarify that before I go on to the summary?
Yes, Dr. Yap.
Yes.
I noticed that you stated earlier that we should use questioning to help our students.
Yes, I understand you now.
And sometimes it's difficult to find the right questions, and then like in communication, it's a skill that we have to develop ourselves to communicate better, right?
Yes.
So I was wondering if you have resources or maybe point out some good books that we can help us improve our way of communicating.
Yes. I will do that. Usually after a session, I will do my reflection on my Facebook page. Later, you will see my Facebook page again. It's just Ban Har Maths in one of the slides. I will give you some resources, but actually, it is not as complicated as that. So the question is, how do we improve our own ability to ask good questions? Yeah, you can read some literature and all that, but actually it's much simpler than that. Let me now share with you the principles of asking questions. So this is in relation to how to help students learn. Yeah. Remember, one of the questions you wanted to discuss is the environment. Yeah. The motivation. So to create a positive environment, one of the answers is going away from explaining, use questioning. Why do I say explaining is not necessary? Not that explaining is something not good. It is good. Explaining is something good. Explanation, while it is important, is something I don't need to do in today's environment. There are so many videos, resources available. That's just one of the many. I just pick it randomly. I just key in, like, explaining maths, polynomial, whatever. You always get like a lot of them. Too many. This one is quite good, I think. Even give the practice question and the solution for the practice and so many other things. It can just be a lesson on its own. Like, boys and girls, today's lesson is watch that video and just do that stuff. Right? And then for those who need help, they can come to me. Anyway, they don't need to come to school to get explanations anymore. If they can understand explanation, videos are good enough. The problem is many people cannot understand explanation. Yeah. So if we do what that guy does, which is not bad really, then some students will never learn. That is because some people cannot understand explanation. And it is not surprising. Who can understand explanation? People who can understand explanation are people who already understood it. Yes, explanation are for people who can understand it. So students who are learning, or the weaker students, cannot understand explanation. So, okay, if I want to do explanation, I can use the video. And the students can stop anytime. That somebody just said, oh, human, we get impatient. But the video will not get impatient at the students. They can stop. They can watch it again. They can watch it 20 times. I don't have time or the patience to explain 20 times. It's just not possible. But students can use the video to revisit any part they want. Yeah. So as a teacher, our job is to ask questions. How do we ask questions? I will share with you some literature, but it's not necessary because it's quite simple to just share it with you in a short amount of time. I always start, you probably noticed that, by asking you something very open. So always start with something very open. Oh, what questions can we answer? Very open. I don't even say angles. Like, what questions can we answer using the information? So always begin with the most open. And let them go and explore. So different people can do different things. If I'm very good, I look at something difficult. If I'm a beginner, I look for something easy I can do. So open question invites everyone. If you ask one question, what is the angle Y? Then those who cannot will begin to get frightened. Closed question is more frightening because I don't know it. And then the fear begins. But if the teacher say, oh, what question can you? Then, okay, I can do this. Then other people who know more can do more. I know a little bit. I can do this little bit. Yeah. So open. Start with something very open. And then we narrow it down to help those who need more help. Oh, somebody say we can find individual angles. I wonder if that is true. Second principle, you don't confirm it. Oh, somebody said like that. I'm not sure. I wonder if that is true. That will reassure the weaker students. Because the moment the teacher confirms something, oh yes, it is true. Very good, John. We can find individual angles. So John, who knows, will feel happy. And those students who don't know will be like, oh, I cannot find it. Now they begin to be fearful that how come John knows, but I cannot. I can only find the sum of B and D. But my teacher said you can find B, you can find D, but I don't know how to do it. So one way to ask question is not to confirm it. So I said, oh, I wonder if that is true, right? So those are the two basic principles in asking question. Start with very open and then narrow it down. And secondly, I don't confirm. I don't confirm right answers. I always say, oh, I wonder if. Other examples, you saw me doing that. Somebody say, use vertically opposite angle. I know what the students say. But then I say, oh, somebody say we can use this. But I find the words difficult. So you notice, I always say, oh, I'm not sure. I am not sure. Those are the two basic principles in asking question in a mathematics lesson. I think we are now at a time where we need to summarize as we end today's session. First question, when students come back to us, when we have a chance to have face-to-face learning once again, how to make mathematics natural? We have heard some suggestions from our friends. Real life context is always helpful. Yeah, that was something shared much earlier. I also share with you, and some of you also pointed that out, it's always useful to keep the problem open so that they get to do exploration. Oh, here is a diagram. Here's a diagram. No question, right? It's just, here's a diagram. What question? What question can we answer? Just like that. So it provides opportunity for exploration. They can explore whether or not they can find individual angle. They can explore whether they can find, if cannot find individual, maybe they can find B and D. Yeah, or maybe other things. They can explore. I did not tell them exactly what to do, but they can explore. Right? But I don't just say, oh, explore, and then end of lesson. At some point, I bring them back and I do a discussion with them. Oh, yeah, what do you think? And somebody say, oh, we know B and D. Oh, that's okay. Is it right? B and D? I don't even ask for the answer, but they were already offering answer. And students can see, oh, my friend got this value. I also got the same value. Think likely I'm correct. Or maybe the friend got other values and then they make a mistake and they got a different value. Then they say, oh, I make a mistake. But nobody knows. Nobody knows. Nothing to fear about. Nobody knows. Only I know I make a mistake. So I can check now. Oh, yeah, I make a mistake. So now my answer is the same as my friend who wrote in a chat box. So this kind of environment makes it less fearful, right? Exploration. But also under the instruction of the teacher, there's also some structure. So remember, in a completing the square lesson, I guide the students and I say, okay, if we have 2x, what's missing? What happens if I have 4x? What happens if I have 3x? So the teacher give them some structure, right? Or earlier on in the star figure problem, I said like, okay, later we can write the rules or the theorems or the properties that we use using words, but also in diagram. Yeah. So to make mathematics learning possible, how can we do it? Always guide them. Always guide them. Always guide them. But you must always let them explore first so that they have a chance to try it first. Many teachers are not reasonable. They go into class and they say, "Good morning, class, let's begin." That's not reasonable. Because students need time to put relevant prior knowledge in the working memory. It's just a human brain process. There's nothing you can do about it. We need a bit of time, a few minutes, to access our long-term memory and put whatever is necessary in the working memory. It's not instantaneous. Humans are not machine. Just switch on the switch. You cannot just step into class and say, "Boys and girls, begin." It's not reasonable. And that is why mathematics is hard to learn. We have used a process that is humanly not really possible for most people. And for some of them, it's possible. Why? Because what we teach them, they already understood. That means that lesson is already learned. So even from the first minute you start, it's okay for them. Why? They learn it already. Or they have gone through training such that their mental process is now perfect. That means they don't need to come to school anymore. They have practiced so much in accessing information that it is now as natural as breathing to them. So the moment you need something, they go and get it. It's so easy for them because their muscles, their mental muscles, is so strong already. But for most students, they don't have that muscles yet. That's why they come to school. But we don't acknowledge that. And we start the lesson straight away. Yeah. So one easy way to make mathematics natural is to change the process. The common process is the teacher straight away start with structure. Boys and girls, pay attention. Listen to me. This is how we do it. It's very structured already. That process is not supported by learning theories. Learning theories always say, begin with exploration. A bit of time. 5 minutes, 2 minutes, whatever. I usually use 10 minutes. 10 minutes is enough time. And then we start the structuring. And that's what I was doing with you. Here's the problem. Go and talk to your friends. 15 minutes later, we meet back again. And then I structure it for you. And over time, you begin to see that you can find individual angles. And then I leave the question whether you can find all the individual angles. Yeah. So make sure we use the right process. We always end with some kind of consolidation. Any question you would like to ask about this? The consolidation can be practiced. I think before that, maybe other things will be good, like writing notes. I often call it journal. It's just writing notes. Practice. And maybe some reflection also. Yeah. So how to make mathematics possible? 2 answers we have today. Maybe there are other answers, but I think the 2 top answers, one suggested by our friend, use real life context, and the second one suggested by me with some contribution from the group, change the process. Process that give students some time. So when the students come back to you, consciously think about this. Yeah. Second and third question, I will answer them together because it's the same answer actually. The belief system, the answer is already given throughout. It's here. Many students believe they cannot learn because the process was wrong. Once we change the process, the belief system will change. They will now believe that actually I can do something. Because the question was open, I can do something. Before I couldn't do because the teacher asked me, what's the value of X? What's the value of Y? And I don't know. So the belief system was affected. In a class where they explore, they talk, their belief system, we talk when we learn. We share ideas when we learn. In the previous format, they believe that when teacher asks me a question, I give an answer. They don't understand that when teachers say, share your idea, they're supposed to share ideas, not give answers. So when the process is changed, the belief system will always change. Yeah, I leave this at that. I invite you to continue to think if you're still not clear on this point. How can the belief system be affected once the learning process has changed? Motivation. How do we motivate students? The answer is also here. This particular process gives students more freedom. This particular process teaches students to be more independent because they must start by doing something with their friends. The teacher hasn't said anything yet. So over time, they learn to be more independent. This format allows students to do what is comfortable to them. Some of them not very good with technical words. Sum of opposite interior angle equals to the exterior angle. It's so hard for them. But because you use a journal, they can write in their own language. They can use diagram if the terms are difficult for them to clarify their thoughts. When they write the journal, they can use everyday language. They can use visual language. Of course, they can use symbols. Of course, they can use technical language. Previously, when they do worksheet, it's always symbols and technical language. They almost never use everyday language. And they don't always use diagrams in the worksheet. The diagrams is given. They don't draw their own. But in a journal, they can. So when we change the process, the motivation and the belief system will automatically change. So actually our answer today is quite simple. Yeah, our answer today to all the question is something very simple. When the children go back to school, when the pandemic ends to become endemic, many things we can do. From today's session, at least two things. And these two things in research have been pointed out as the game changers, meaning something that can change fundamentally how students learn and how students perceive mathematics. I would encourage you, as I always done, when you do a lesson, always begin with an open problem. Let them try first. Let them talk. Let them interact, whether online or in groups. Let them do it first. And then when they meet us, structure. Remember the important thing about structure? Don't explain. Use questions. What else is important about structure? Other than don't explain, use question. Yes, it's focus. Don't explain everything. When I say explain, I mean explaining the way I was demonstrating it, using question. Don't explain everything. Yeah, that's right. Focus. Have a focus. Pick the one that you find students have greatest difficulty, whether it's completing the square or interpreting the completed square. Just focus on one. So I would imagine completing the square might have 2 or 3 lessons. So maybe the first day lesson is just on completing the square. And then the second lesson is on interpretation of the completed square. So 2 important things to remember for structuring. And then of course for consolidation, there are many things we can do. So if this is something you can put in place when students come back to you in the class, and everyone in your school does it. In every school in Indonesia, do it. If that can happen, that would be a recovery from the pandemic of students not learning well. All right. So anything else you would like to bring up as we end today? I'll pass the session back to Fitra.
Yeah, thank you, Dr. Yeap. Okay, thank you, Dr. Yeap, for the insight and ideas you have shared with our teachers. I'm sure our teachers are enlightened, yeah, and they will be able to help their students learn better. Okay, so educators, it is the end of today's session. Hopefully, this session has provided you with a lot of insight and ideas for teaching development. On behalf of Mentari Group and Singly Education, we would like to say thank you and hope to see you all in the next event. Stay healthy and have a nice weekend, everyone.